Hi there, and welcome back to the e-learning video series on BSF Biowaste Processing. This module, in the BSF Business Development chapter, will focus on the site design. After watching this model, you'll be able to understand the aspects to consider when selecting the site location. You'll also understand the climatic and environmental conditions required when operating a BSF site. You'll be able to analyze the spatial requirement for the BSF system with a fixed amount of biowaste processed per day. And lastly, you'll be able to apply data from the web-based cost model and site design to produce work schedules for the operators.
The first thing we're going to look at is what aspects are important when looking into selection of the site location. First of all, we have to make sure that there is availability of a nearby source of biowaste in sufficient and predictable amounts. Then we have to make sure that the customers for the fresh larvae and that other markets for post-processed products are not too far from the site away. Then we have to make sure that the areas where adjacent land users may find a waste processing facility inappropriate should be avoided. We also have to make sure that water and electricity supply is available at the site and that there are wastewater treatment facilities available. We have to have an adequate buffer zone that separates a facility from the surroundings so that, for example, the flies will be flying out of the cages into the area without directly disturbing neighbors. Then the treatment building itself should have at least have a concrete floor and a roof to ensure a safe and clean working space that shelters against the weather and that has space for an office, toilet facilities, and a lab. So in summary, it's important to ensure that your raw materials and your product market are in the near vicinity of the site. It's important that you want to make sure that your activity do not disturb others. You have to make sure that the water and electricity supply are available, as well as a wastewater treatment system. And for the site, you want to ensure that a green buffer zone is available, that your treatment building has at least a roof and a concrete floor, and that there is enough space available for an office, toilets, and a lab. The site and all its process units should be kept clean of vermin. Installing a mesh wiring for the most essential components and placing the legs of the custom-made racks into end traps so that ants cannot climb up. Then we move to the specific process units, starting with the treatment unit. This unit ideally has a lower humidity and a temperature of around 25 degrees, with full shading of the sun, to make sure that the substrate can dry out fast enough and that the larvae are not disturbed by sunlight or by a higher temperature, which quickly would increase the substrate temperature. For the rearing stage, there are quite some environmental conditioning steps required. For the egg and pre-pupae stage, as well as for the pupae stage, the high humidity is required and a temperature of around 28 degrees will be suitable with full shading of the sun. This is to ensure that at this stage the BSF do not dehydrate. During the larval stage, the BSF require a lower humidity and lower temperature level, with full shading from the sun. For the fly stage, again the high humidity and high temperature of around 28 degrees is required, but with an abundance of light, although be it indirect sunlight, so not direct sunlight on the environment where the flies are in. Then, for the post-processing unit, what is important is that there is enough ventilation available and a comfortable temperature for the operators to work in. A low humidity will help increase the storability of the products stored in the post-processing room. So in summary, the entire site should be kept clean of vermin. For the treatment unit, a lower humidity and temperature in combination with no sunlight is best. For the nursery, the egg, pre-pupae and pupae stage require high humidity, high temperature and no sunlight. The larvae stage require low humidity, low temperature and no sunlight. And the fly stage require high humidity, higher temperature and an abundance of natural light, although no direct sunlight. Lastly, the process room needs sufficient ventilation and a comfortable working temperature in combination with a low humidity for improving the storability of the products. We have already introduced to you the web-based cost model. One of the outputs of this model is the space requirement needed for the different processes. So when we now look at the spatial design of the site, you see that the core processes are divided into 3 sections. From left to right are the post-processing section, the waste treatment section, and the rearing unit. The different processes and the spatial design for the unit where each process is happening can be subdivided into different process steps. For example, for the waste treatment, we have the pre-processing and the harvesting step. In addition, the core activity, there are other facilities at the site that require space. For example, the employing facility, the office, and additional storage and laboratory space are just some examples. The buffer zone around the site is highlighted here by the trees and bushes that you see around the buildings. What is important is that raw materials and the products should be received and collected without disturbing the other processes. This means that the waste processing and BSFL post-processing should be near to each other and near to the exit of the site, which in this case is on the left of this overview. We're now going to look at how the scale of the amount of waste that you should treat affects the size of each of these different operational units, in an effort to give you an idea about how a site scales to an increased input of biowaste. We will be looking at a scale of 5, 2, and 1 ton of biowaste treated per day. And we will be first showing you the results of the web-based cost model, meaning the results of the space requirement, and then showing you how this affects the floor plan of the site. So first, a 5-ton site. This shows a space requirement for the nursery of 121 square meters, the waste conversion space with a requirement of 678 square meters, and the post-processing to have a combined space usage of 105 square meters. The results is the following floor plan that you can see in front of you. Now, when we look at the 2-ton site, we see a space requirement of the nursery of about 71 square meters, a waste conversion space requirement of around 286 square meters, and a post-processing requirement of about 57 square meters. And that results in the following floor plan. Here it becomes clear that the post-processing unit does not scale similar to other units. This is mainly due to the minimum capacity of the equipment required. Even for a lower amount of BSFL produced per day, still the same equipment is required to process the larvae. Now lastly, for the 1-ton site, it shows a space requirement for the nursery of 47 square meters, a waste conversion space requirement of 160 square meters, and a post-processing requirement of about 44 square meters. Again, the scale reduction of the post-processing unit reduces less compared to the other units. It is important to prepare these scenario plans before setting up your BSF facility and plan for the scale at which your plant will be operating. What you see in front of you here is the Excel file which you can export from the web-based cost model. This example uses the 5 ton of biowaste input per day. What we're going to be looking at is what the effect is of the input material on the operational schedules, which is in relation to the operational time that you select with a certain waste input. For this, we zoom into the CapEx, or the investment cost of the site. On the left, you see the different operational units, where the bottom 4 items combined being the post-processing unit. The column next to this overview lists the equipment items, which are used at the BSF Biowaste Processing facility in Indonesia. To the right of this column is a value which indicates the amount of a certain equipment item which are needed for this scale. This value is the result of a calculation of this scale, in this case the 5 tons of waste per day, and a certain capacity of the equipment item. This capacity is important as it will define the number of times a certain equipment item has to be handled, and therefore will impact the number of operators required and the work schedule which they will follow. Let's highlight one item and use this as an example to show you how to prepare your work schedules for the operators. Here we see the loft cage highlighted. 24 units are needed to hold all the flies, which will lay sufficient eggs to produce the 5-day-old larvae, which will treat the 5 tons of waste per day that we selected. We previously learned that the fly stage takes 4 days. This means that to accommodate the flies in the loft cage, knowing we need 24 units, 6 fly cages would have to be set up each day to accommodate the flies. When looking at the operational schedule, the activity would have to take place every day, and not 2 cages, but 6 cages will have to be set up per day. Using this example, the web-based cost model can help you define the space required per unit and also the equipment required for a certain scale. These values can help you to adjust the work schedules to fit that selected scale. So we have now almost come to the end of this module on the site design. Here is a Q&A refresher with 2 questions for you. The first question: name at least 3 site selection criteria. Some of the selection criteria are the nearby sources of biowaste, the roof and floor availability, office, toilet and lab availability, green buffer zones, access to utilities, and near to target markets. And here's the second question. What are the main factors mentioned in the environmental conditioning part? The main factors are humidity, temperature, and light intensity.
We've already come to the end of this module on the site design. You learned that there are multiple factors which affect the selection of a site location and climatic control measurements. You've also learned that the scale of a plant has a strong impact on the floor plan and does affect each operational unit differently. Lastly, you learned that work schedules can be produced from a desired scale of operation. Thank you for watching this module, part of the e-learning video series on BSF Biowaste Processing. More information can be found in the BSF step-by-step guide, which you can download through the QR code here. Both of these materials were part of the Forward project by EWAC, in collaboration with the Ministry of Public Works in Indonesia and funded by SECO, the Swiss State Secretariat for Economic Affairs.